Okay, Amy, here's another example of rationalising the denominator because you seem to be confused about the process, so I'll try to step it out one more time. So if I've got 2 over 3 plus root 2 and I want to rationalise it, I want to make the denominator rational because at the moment it's irrational because it contains surds. So I need to multiply by its conjugate. So what its conjugate means is exactly the same thing as what you have here, but I swap the sign from positive to negative. So I've got to multiply that over here, but also up the top as well, so that in order for me to have a total of 1 that I'm multiplying by. Because 3 minus root 2 divided by 3 minus root 2 is actually 1, so I'm not really changing anything. So if I go through the multiplication, I end up getting 2 lots of 3 minus root 2 in the top row, and 3 plus root 2 times 3 minus root 2 in the denominator. So using my expansion, 2 threes is 6, and 2 times negative root 2 is minus 2 root 2. Then my denominator is a difference of 2 squares. So I've got 3 threes and 9, and root 2 minus root 2 is 2. And I can only perform that quick expansion because I know it's a difference of 2 squares because they look exactly the same bar the plus and the minus. So that leads me to a final answer of 6 minus 2 root 2 over 7. And a slightly more complicated one here, if I have 2 root 3 minus 5 over 7 plus 3 root 5, again I multiply the denominator by its conjugate. So the only thing that changes is the positive to a negative. If I had a negative here, it would be a positive here. But in this case I don't, so positive and negative. So again I multiply the same in the numerator as I do the denominator. Now I've got 4 terms up the top here. So really I'm multiplying that one first. 2 root 3 times 7 gives me 14 root 3. Then that one second, 2 root 3 times minus 3 root 5. So outside, 2 times minus 3 is minus 6. Inside, 3 times 5 is 15. Then I do the next lot, minus 5 times 7 is minus 35, and minus 5 times minus 3 root 5. 2 negatives make a positive, 15 root 5. Again, I'll get the same situation on the bottom, so I'll get my difference of 2 squares, as you'll always get, and that's the whole process of rationalising the denominator. You'll always get a nice number coming out of it, and that's the whole point of it. So 7 squared is 49, and 3 root 5 times 3 root 5 is 9 times 5, because root 5 times root 5 is 5. If I clean that up, that leaves me with 4 in the bottom. I look at the top here, and if these surds were able to be broken down, I would continue on simplifying. But I've got root 3, root 5, and root 15, all which can't go any further. So therefore I just leave it as it is. So hopefully this sheds some light on your on what you're going through, and it clears it up for you so you can be ready to do the test tomorrow. See ya.